Hello, I'm Mrs. J, and today we're going to cover section 5.7, compounded interest, and the number E, which is compounded continuously. Compounded interest, n times a year, uses this formula. This P is the amount at the end. P sub 0 is the starting amount. Initial amount, present value, and this one's called future value. R is the percent as a decimal. N is how many times it's compounded, like how many times a year. And T is the number of years. So if we put $600 in a savings account at 6.5% compounded monthly, how much is there in 5 years? So we want to know how much there is at the end. The starting amount, we put $600 in. 1 plus our interest rate, as a decimal, it was 6.5, so it'd be 0.065 divided by n, which is compoundings per year. If it's monthly, it's 12 in a year. And then our exponent is 12 times the number of years, which in this example was 5. So then we just plug that into the calculator. 600 times 1 plus 0.065 divided by 12 to the, now if you don't enter this as 60, you do need to have it in parentheses, 12 times 5. $829.69. So if it's a compounded amount, monthly would be 12, quarterly would be 4, semi-annually would be twice a year, but quarterly, monthly, and yearly, those are the most common. Monthly's 12, quarterly is 4, semi-annual twice. We could also find the effective rate, because if this is compounded monthly, we could find out effective rate is approximately how much it is per year. So the variables are the same. 1 plus R was 0.065 over 12, because it was monthly, and then 12 minus 1. So 0.065 divided by 12 to the 12th minus 1. We get 0.06697. Now we need to make it a percent. So 6.7%. So 6.5% a month is approximately 6.7% per year. We also have compounded continuously. So instead of monthly, daily would be 365. It could be compounded continuously. Continuously uses the exponential function. But the rest of the values, they all are the same. And E is this function in your calculator right here. So if we have $1,000 in an account at 8% compounded continuously, how much is there in 3 years? So plugging it in, 1,000, E is the function in your calculator, And then R is the interest rate as a decimal, so 0.08 times the number of years. So I plug in the 1,000, second in E, and then the percent, 0.08, times the number of years. And then hit enter. $1,271.25. So there'll be $1,271 in the account. To find the effective rate, we use this formula. And if we keep with the 8% from the problem before, it would be e to the 0.08 minus 1. Now what you need to be careful with on this one, we do our second e to get e up, then 0.08. You need to close the parenthesis before you subtract the 1, because the 1 is not up in the exponent. So close your parenthesis before you subtract 1. It's not up here, it's down here. We hit enter, and we get, and these will be close, 3287. And multiply it by 100 to make it a percent, and we get 8.33%. And so that's our compounding interests. Okay, for growth and decay, they set up the problems but don't do very much with them yet. And so when we're talking about growth and decay, C is your starting amount and K is a constant or an instantaneous growth or decay. And then T is time. When K is greater than 0, it's a growth. When it's less than 0, it's a decay. So if we look at this one, we have 500e to the 0.2t. Is it a growth or a decay? Well, it's a growth because it's 0.2. To rewrite it as this, we did one problem similar to this already. To rewrite it, you take, this stays 500, and you just use this part. And we take e to the 0.2 t. So if we find e to the 0.2, we get 1.22t, which means this is a growth. So 0.2 is the k value. This would be a growth. To find the rate, we subtract the 1 out. The rate as a decimal is 0.22. As a percent, multiply by 100. So it's a growth of 22%. This one, again, well, the negative means it's a decay. To rewrite it, second e, and it was a negative 0.3, which gives us 0.74 to the t. This is less than 1, so it is a decay. Or we already said decay. But to find the rate, we get 0.26. So it's a decrease of 0.26, or whoops, we don't need the negative. But it's a negative 26 because it's a decrease. But we don't have to have the negative there. So when we multiply by 100, we get 26%. So it's a decrease of 26%. And that's everything in this section.